All right, this is my ECE 363 Lab 6 presentation video, or a demo video, I think it's actually called. So, for my project, I did the servo motor controller. So, the goal of this is to control the position of a servo arm with a potentiometer. So, you want full 180 degrees of the servo arm movement, and you want that to correspond to moving the potentiometer back and forth. All right, so let's get into the circuit. So, let's see. Yeah, I think that's better. So let's get the servo in view. All right. So, let's go left to right. So here is the voltage supply for the left half of the circuit from my point of view. The 9-volt battery. Here is the potentiometer. That is the timer. That is the comparator. That is the octocoupler. And this is the linear voltage regulator, which provides the 5-volt supply for the servo side. So how it works is the timer creates a triangle sawtooth wave, and the voltage creates and the potentiometer creates a variance in voltage. So so both of these signals are fed into the comparator, and when the potentiometer voltage is greater than the triangle wave at any given moment, it turns on, creates a high. So that creates a nice pulse. And then varying the potentiometer voltage creates a pulse of different lengths, and that creates a nice PWM signal that is used to control the servo. So if you can see, we have a nice about 180 degrees of motion on this servo. Oh, not 180, 160. Not the full 180, but I think 160 degrees. It's hard to eyeball and it's hard to measure. That is what we got. So here, all the way to the right, we have a voltage of 4.84 volts. And then at 0 degrees, we have a voltage of 4.9, oh, it's really jumping, 4.96 volts. And then at its full 160, we have a voltage of 5.04 volts. And the reason I keep taking the multimeter in and out of that position is because it messes with the servo position. If you leave it in there, it throws everything off, so it's easier to take and remove. But yeah, this is it. Control the servo with the potentiometer. So let's look at the oscilloscope. So here it is. Let's make sure that's caught on camera, and it is. All right. So as you can see, as I change potentiometer voltage, it lengthens or shortens that pulse. So this is about the 160 degree position. It is, or I guess that'd be negative 70. I've sort of been mixing my units here. It is just under 1 millisecond. And then when I move it all the way over, it is about 2.7 milliseconds. So what you want, so it's a 50 hertz signal is what the servo takes, which the oscilloscope automatic measuring of there is quite a bit off. but and you want around like from 10 to 5% duty cycle. So that corresponds to about a 1 second to 1 millisecond to 2 millisecond pulse. So that is what we got. And then here we have the plot. That's measuring. Oh, it's not picking that up. Oh, is it? Let's make it full screen. There we go. There we go. So this is the duty cycle versus potentiometer voltage. So as you can see, as the potentiometer voltage increases, the duty cycle goes down. So the hard part in measuring this is the 9-volt battery. The voltage on it decreases over time because it's a battery, it's running out of charge. So as you measure more things, the comparative voltage that corresponds to a given servo arm degree position changes, which messes a lot of things up. So you can't get too many data points all at once or at all because the voltages are constantly changing. But yeah, that is my circuit. That is my servo motor controller. I hope you enjoyed.